All right. So 4.6 applications of logs and exponentials is literally just real life problems. So we're going to go over these. There's formulas to use. You can flip back and forth to those formulas. It's not a big deal. Okay. So don't stress out about memorizing them. The ones that you probably need to memorize, you should already know this one. This one is growth and decay. But the ones that you definitely need to memorize for your final exam are probably these two, the PERT. Those four will be the big thing. We will not use this one at all. It's too complicated. They're not going to have it on the final exam. And this one is just a modification of growth and decay. So it's really easy to remember. PERT is also easy to remember. And then this is a half-life, and this is not my favorite half-life formula, but it's what you get. Okay. So this one, and your problems will say it, you're going to use for compound interest. Compound interest. So it'll say interest compounded, blah, 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 blah. So when it talks about this compound interest, there's a couple things that they'll tell you. They'll tell you monthly. So it'll say deposited such and such amount, $100 into the account, and it compounded monthly. So how many times a year would it compound if it's monthly? 12. So you're going to use 12 for your N. Okay, so your N would be 12. There's quarterly. How many quarters are there in a year? How many quarters are there in a dollar? 4. So your N would be 4. And then semi-annually is going to be 2 times a year. Okay, so make sure that you know those. Semi-annually, so A-N-N-U-A-L-L-Y. All right. Then the next formula, P times 1 plus or minus R to the T is growth or decay. Appreciation, depreciation. So you buy a car for $30,000 and it depreciates 10% per year. That's one of your decay formulas, okay? Plus for growth, minus for decay. Right. I call this the PERT formula, P times E to the RT. Watch this one. It literally says compounded continuously. Compound continuously. And then the last one uses a half, and it's for a half-life. So I'll explain half-life for a minute. Isotopes have what they call half-lives. How long does it take for half of the atom to break, or the isotope to break down? So when, I know this goes a little bit morbid, but listen carefully. How do they tell when they find a body how old the body is or how long it's been dead? They carbon date it. You guys have done that with fossils. Well, not you personally, but you've heard about carbon dating with fossils. That's how they know how long ago a woolly mammoth lived. Does that make sense? Okay. So what they do is they test the remains for the carbon, and they see how much carbon remains within that. And then after they test that carbon, they can see how long. So that's your half-life. Every so many years, half of the isotope breaks down. And so you'll see that, and it will like deal with some kind of carbon, radium isotope, okay? So all of this down here tells you what these numbers stand for, these letters stand for. A is the end, P is the initial, that's principal, that's why they use P, the principal amount. R is the rate, so that's going to be your percentage, but you need to make sure it's in a decimal. So if they give you 40% as your rate, you're going to change it to a decimal by moving the decimal over 2 places. So make sure that you write it as a decimal, okay? Even if it's like 2.5%, you're going to move that decimal 2 places and use 0.025, okay? So always change it to a decimal, not a percentage. And then the time is going to be how long you do that. N is the number of times the principal is compounded. Like I told you, it could be monthly, quarterly, semi-annually. It could be 9 times a year. Just listen to what or read what the problem tells you. K is your half-life. So like carbon, and it'll tell it in a minute, carbon is like 5,620 or something like that. You'll see it in a minute. That's how long it takes for half of it to break down. So it takes a long time for half of the isotope to break down. So that's what that is. And then we're not doing monthly interest rates, so you don't need to know. Okay. Any questions? All right, so we're going to go right into it. So we're going to look at the first problem. It says $800 is deposited into an account that pays 9% interest. It says compounded quarterly. So that means 4 times a year. And it said compounded, so we know it's that first formula. So if you guys look back on your paper, that first formula was for compound interest, not compound continuously, just compounded. So we're going to use this formula right here. So I'm going to write it down. A equals P, that's your principal. How much did you put in to begin with? 1 plus R over N, your rate over the number of times it's compounded. And then to the NT, number of times it's compounded times how long you're compounding. So how much should we start with? How much should we deposit? One plus, what's our rate? Remember your rate is your percentage. So what's our percentage? 9%, and we're going to change it to a decimal, so 0.09. How many times a year are we compounding it? 4, because it's quarterly. Again, same thing, 4. And then how long are we doing it? Find the balance what? After 4 years. You're literally just typing this into your calculator. So 800 parentheses 1 plus 0.09, delete that, over 4 parentheses to the 4 times 4. And we get, after 4 years, the account will have $1,142.10. And again, round like money because that's what we're using. Right. So I'm just going to go through and do all of the ones that are compounded quarterly, yearly, whatever. So the next one is not, this one is compound continuously. We'll come back to this one. We're not doing the house. You guys can mark those out. Here's compounded continuously. New car. Here's one at the very bottom. Dylan, I hope that helps. All right, how much must you deposit into an account that pays 6.25 interest, compounded semi-annually? Remember, semi-annually is 2. We have 6.25%, but we're going to move that decimal 2 places. So 0.0625 is what we're putting in our formula. To have a balance of 1,000 after 2 years. Now watch this one, okay? We want to know how much we deposited, so we want to know P. So we're going to have to plug into our formula. Okay. So how much should we have in the end? A is how much we had in the end. 1,000. We don't know P. 1 plus, what was our rate? Our rate is 0.60625. How many times a year are we doing this? 2. 2 times a year, and then it says after 2 years. So the N and the T on both of these problems have been the same. They won't always be like that. All right. We're going to put all of this in our calculator and get whatever decimal we get on that. 1 plus 0.0625 over 2 to the 2 times 2 gives me 1.1309. I'm going to go 4 decimal places, and you don't have to round that 4th decimal place like we talked about the other day. So we get 1,000 equals 1.1309, and then we have P. How do we solve that? Divide by 1.1309. So in my calculator, 1,000 divided by that gives me, I need to deposit 884.25. All right. Any questions so far? I'm going to go back and do the compounded continuously ones because those are easy to find. So number 3 was one of them. I know we're skipping all around, but I want to do the same one over and over again. So number 3 was compounded continuously. That formula is your PERT formula. Remember, E is like pi. It's just a symbol. It represents 2.7181828. I don't know what it is, but it represents a number. So that's going to stay there. You're not plugging in for that, okay? But you will plug in for 3 of the other 4 letters. So it says 600 is deposited into your account. Where does that go? P. Remember, E just stays there. 6.5% interest. Move it 2 decimal places, gives us 0.065, is your rate. Compounded continuously is how we knew we used that formula. What is the balance after 5 years? So the time is 5 years. And you're literally just putting that into your calculator. And we get 830.42. And again, rounding like money because we're talking about money. Any questions? All right. Number 5 is also compound continuously. So A equals P times E to the RT. It says, how long will it take? That's your T. How long will it take an investment to triple? What does that mean, triple? Times 3. In an account that pays 8.5% annual interest. So we're going to change that to 0.085. Do we know how much we put in to begin with? We don't, right? So how do I know how to triple it, or how much do I know what I want in the end? This is exactly what you do. If you put in 1,000, what's triple that? 3,000. If you put in 10, what's triple that? 30. If you put in 1, triple that? 3. So we're just timesing by 3, right? So when you see this and it doesn't give you anything, we want 3 times as much as the 1 we begin with. It's always going to be 3 and 1. If it said doubled, it would be 2 and 1. If you want to put random amounts in, it works the same way. Okay. So if you would have done what I said and put 10 and 30 or 1,000 and 3,000, it works the same way. So don't stress out about that. If they don't give you an amount, you can make one up as long as you triple it in the end. All right. E, our rate is 0.085 to the T, and we're solving for that T. So remember, this 1 in front really doesn't matter, but if you actually put a value in there, we want to get rid of it first by dividing by that. So we still get 3 equals, and you should get 3 in the end. It should be a triple. E to the 0.085 T. Now from Friday, how do we get rid of E? Yeah, LN both sides. So we're going to get rid of E. So we're going to LN both sides. So that marks out. We get LN3 equals 0.085 T. How do I solve for T? Yeah, don't worry about the LN3. I divide by that, just like normal. And the reason I don't do the LN3 is it's going to give me some crazy decimals, so I'm not real worried about it. I'm going to do it all at one time. So I'm kind of lazy. Hit my LN key 3 over 0.085, and I get 12.92. So approximately how long will it take to triple your account? Approximately how long will it take to triple your account? Is it 12? Yeah, pretty much 13 years. So they'll probably approximate this to say approximately. And how do you know it's 13 years and not like days or months or whatever? What does it tell you? Right here. How many times a year do you get an annual or a yearbook? One. It's every year. Okay, once a year. So approximately 13 years. All right, we're going to go back up to number two. Number two. It says you have inherited an emerald ring that had an appraised value of $2,400 in 1960. The appraised value of the ring has increased by approximately 6% each year. What is the value in 2011? So which formula are we going to use? We know it's not any compounding, so it's either growth and decay or it's half-life. If it's a half-life formula, it will say half-life. So this one has to be growth and decay. Is this one growth or is it decay? Say it again. Growth, because it says increased. So we're going to use plus. 1 plus R to the T. So how much was it worth in the beginning? 2,400 in 1960. What's our rate? Mm-hmm. So we're going to take this 6, the decimal's back here, move it 2 places, so 0.06. And then how long did it happen? How do you figure that out? How do we figure out how long? Guys, come on. Right, so how can we figure out how many years that is? Yeah, actually, just put it in here like that. Remember, I'm really lazy about some math. You know what I'm saying? You don't have to do that in your head. You can do it in your calculator. You don't have to do it separate. You just put it up there and your calculator will do it for you. And I know that I preach using the calculator, but you have the calculator for the entire test. So why not use it? Okay. Why not use it? So now it's just plugging it in. 2,400, 1 plus 0.06 to the 2011 minus 1960. And we get 4686087. That's how much that ring is worth now. It's probably a pretty big, hefty emerald ring. Is everybody good? All right. Down at the bottom, number 6. Same thing. For Dave to buy a new car comparably equipped to the one he bought years ago would cost $12,500. Since Dave bought the car, the inflation rate, inflation means what? Increase. Rate for the cars like this has been an average annual rate of 5.1%. If he originally paid $8,400 for the car, how long ago did he buy it? So we're looking for T. How long ago? So same formula. Sorry, that's not what I wanted. A equals P times 1 plus R to the T. And again, it's plus because it's inflation. What was it originally? Say it again. What was it originally? 8,400. That 12,500 is where I'm going now. How much would it cost now? So presently, or A, would be 12,500. 1 plus, what's the rate? Take that percentage, move it over. So what's our rate? Mm-hmm. 0.051. And then we're looking for the time. We're looking for the time. All right, so we're going to clean this up. We have to get this power by itself. That's what we're looking for. So the first thing you need to do is get rid of this 8,400, just like I did right here. To get E by itself, we got to get rid of that power. That's what we were working with. So we got to divide that number out first. So we're going to divide by the 8,400. So we get 1.4881. I'm going to put these two together so it's a little bit easier to look at. 1.051 to the T. There are two ways to work this. You can do left, right, middle. You're going to have to log anyway, left, right, middle. But the problem is the power's on the incorrect side. Hold on just a second. Sorry, guys. Hold on.
Students, part of the interruption, but we are going to begin our registration process today. So at this time, any student who is in the building that is in the 9th through the 11th grade with last name beginning with the letter A, please head to the commons area. Any student 9th through 11th grade, last name A, please report to the commons area. Thank you.
So if it's, yeah, aren't you 9th through 11th with the A? Okay. Everybody good? All right. So to get this down, you can do two things. You can do left, right, middle, but you got to remember to put the power on the other side. Like you have to switch this equation. So if you're going to do left, right, middle, the power has to be on the left side. If you don't remember that, just log both sides. We want to get that power down. You could ln both sides. It doesn't matter which one you choose because remember ln is still logging, right? So it's all the same. So we can log both sides. And the reason we do that is because now we have that power can come to the front. So this is what it's going to look like. Log of 1.4881 equals T, and I'm sorry, I'm squishing it up, log 1.051. To get T by itself, we're going to divide by this log 1.051. So those will cancel and it'll leave me with T. And the reason I don't go ahead and do, I don't want a bunch of different decimals. So log 1.4881 over log 1.051. Oh, delete that. And we get 7.99. So approximately how long? Yeah, approximately 8 years. And that's it. Okay, so that's your first page. I don't know if there's any on the second page or not. All right, everybody good? All right, so that's all the notes. Let me look and make sure. I don't know why there's not any half-life. So we're going to find some half-life and do those. Let me find one. Oh, there it is. 13 on your homework. So this is actually on your homework, number 13. And I think it's the only one with a half-life. Okay, everything else is going to be growth or decay. So again, you see it says half-life. So we're going to use our formula. A equals P times 1/2 T over K, and K is how many ever half-lives it is. So the half-life of CS-137. The 137 means absolutely nothing. This is the name of the isotope. Okay, so 137 is not part of your problem. It's just naming the isotope. Is 30.2 years. This is your K. That's how long it takes it to break down. The initial mass of the sample is 1 kilogram. So that's P. Your initial is 1. How much will remain after 151 years? That's your T. 151 years. It takes it 30.2 years to break down. And we're looking for the remaining. How much is left over? You literally just put this in your calculator. So 1 times 1/2 to the 151 over 30.2. And it leaves you with 0.03125 kilograms. So it is the same exact way, okay? Same exact way. Make sure there's not any more weird ones. You can do this one without plugging it into a formula at all. So we start with 128, and then so we start with 128. After round 1, it says half the players are eliminated. So what's the number? What's half? What's half of 128? What's half of 12? What's half of 8? At round 2, how many are left? After round 2, 32 are left. After round 3, I'm gonna go ahead and tell you, 16. After round 4, half of 16 is 8. Guys, I don't know what's happening to my, hold on. It did this last week too. Give me just a minute. I'll turn it back on. Just randomly decides to stop. There we go. And then after round 5, how many are left? 4. So that one's pretty quick. You didn't have to do any work. All right. I'm trying to see if there are any with the house, like any of that. It doesn't look like it. I think you're good to go. The rest look like growth and decay, so I think you're going to be fine. I don't really see that much. There's an annual rate, so that's compound interest, not continuously. Or it's also growth and decay. I think you're good. Everything else is pretty much growth and decay that you need to work on. All right. So I'm going to stop sharing and stop recording.